applications to secure design concepts, secure coding guidelines to common pitfalls. It's sprinkled with stories, examples with Alice or Bob, and diagrams. It also covers testing and deployment, but it's certainly not a book about hacking. It's about how to ensure that your applications are tough, rugged, and secure. The book describes how to create an AppSec program, how to secure modern technologies and systems, habits for developers or anyone to keep themselves and their systems safe, and even includes a learning plan at the end. With tips, tricks, and even jokes, this is not your average textbook. I hope that you enjoy this book as much as I did, and that you decide to fight the good fight with Tanya and me by building secure software. Jim Manico, founder, secure coding instructor, Manicode Security. Introduction. Why application security? Why should you listen to this book? Why is security important? Why is it so hard? If you have picked up this book, you likely already know the answer to this question. You have seen the headlines of companies that have been hacked, data breached, identities stolen, businesses and lives ruined. However, you may not be aware that the number one reason for data breaches is insecure software, causing between 26 and 40% of leaked and stolen records. Yet when we look at the budgets of most companies, the amount allocated toward ensuring their software is secure is usually much, much lower than that. Most organizations at this point are highly skilled at protecting their network perimeter with firewalls, enterprise security, blocking malware and not allowing admin rights for most users, and physical security, badging in and out of secure areas. That said, reliably creating secure software is still an elusive goal for most organizations today. Why? Right now, universities and colleges are teaching students how to code, but not teaching them how to ensure the code they write is secure, nor are they teaching them even the basics of information security. Most post-secondary programs that do cover security just barely touch upon application security, concentrating instead on identity, network security, and infrastructure. Imagine if someone went to school to become an electrician, but they never learned about safety. Houses would catch fire from time to time because the electricians wouldn't know how to ensure the work that they did was safe. Allowing engineering and computer science students to graduate with inadequate security training is equally dangerous, as they create banking software, software that runs pacemakers, software that safeguards government secrets, and so much more that our society depends on. This is one part of the problem. Another part of the problem is that English language training is generally extremely expensive, making it unobtainable for many. There is also no clear career path or training program that a person can take to become a secure coder, security architect, incident responder, or application security engineer. Most people end up with on-the-job training, which means that each of us has a completely different idea of how to do things, with varying results. Adding to this problem is how profitable it is to commit crimes on the internet. And with attribution, figuring out who did the crime, being so difficult, there are many, many threats facing any application hosted on the internet. The more valuable the system or the data within it, the more threats it will face. The last part of this equation is that application security is quite difficult. Unlike infrastructure security, where every version of Microsoft Windows Server 2008 R2 Service Pack 2 is exactly the same, each piece of custom software is a snowflake, unique by design. When you build a deck out of wood in your backyard and you go to the hardware store to buy a 2x4 that is 8 feet long, it will be the same in every store you go to, meaning you can make safe assumptions and calculations. With software, this is almost never the case. You must never make any assumptions and you must verify every fact. This means brute force memorization, automated tools, and other one-size-fits-all solutions rarely work. And that makes application security, as a field, very challenging. Pushing left. If you consider the System Development Lifecycle, SDLC, the various phases move right. Requirements come before design, which comes before coding. Whether you are doing Agile, Waterfall,